We have already added some functionality to our RESTful API. We added our first routes for products and orders, but we don't really work with the data we get. We don't manage that data. We have no database. We are going to change it in this video. We are going to add MySQL, so let's dive into that. All database changes we will make via migrations. If you are not familiar with migrations, consider them as a version control but for a database. To handle migrations, we are going to use Doctrine migrations. Install it. Composer require Doctrine/migrations. Now we need to configure them. In the root of the project, create a folder migrations. Here, Doctrine will store migration classes. Then we need to tell Doctrine about this folder. Also, in the root of the project, create migrations.php file. Inside, return an array with two keys: migrations underscore namespace, let's name it app migrations, and migrations underscore directory. Here provide our folder. Then we need a database config file for migrations. Again, in the root, create a new file migrationsdb.php. Inside, return an array. We provide a database name, user, password, host, and driver. Of course, we don't have shop database yet, so let's create it. In the terminal, I run MySQL admin create database shop, username root, and password. Done. Now we are ready to generate our first migration. Run Doctrine migrations generate. It will create a new migration class here in migrations folder. Open it. Here in app method, let's define schema for products table. Create table products, ID unsigned integer, auto increment. Name is a string of 60 characters and decimal price. ID column will be a primary key. This add SQL and provide the schema for our table. Method down is used when we want to roll back this migration. Here we draw products table. Our first migration is done, so let's run it. In the terminal, type Doctrine migrations migrate. So it finishes. Let's see what we have in our database. To view the database, I use PHP Storm, user root, and database called shop. So here is our database. Now it contains two tables, one for applied migrations, and here is our products table. Let's add one more table for orders. Again, run Doctrine migrations generate to create a new migration. Open a new migration class and add SQL queries. Create table orders. We have an ID, a product ID, and a quantity. ID column is a primary key, and product ID is a foreign key that references products table. In method down, we drop the table. Done. Again, run doctrine migrations migrate to apply these changes. Okay, refresh the view. Here are our tables: migrations, products, and orders. The schema is ready. Now let's make a connection to our database. To work with MySQL in React PHP, we need to pull a package, Friends of React PHP MySQL. It is an async MySQL client for React PHP. Open the terminal and type composer require react/mysql. So, first of all, we create a factory for connections. Provide an event loop here. Then we use factory to create a lazy connection. Why lazy connection? The idea behind it is that internally it lazily creates the underlying database connection only on demand, once the first request is invoked. All outstanding requests will be queued until the underlying connection is ready. Provide a connection string that contains username, password, host, and a database name, which in my case is root, no password, localhost, and shop. These values from migrations config. Okay, the problem now is that we have database credentials in two places, in migrations config file and here. For such things as database credentials, it's better to use environment variables, because then we can set this up on the server we deploy our application to, so we don't have to hard-code it here in the source code. Now, to use environment variables in PHP, we can use a package called php.env. Install it. Okay, now for environment variables we can create .env file and put credentials there. Here we put database name, login, password, host and driver. Because environment files store sensitive passwords and API keys, it is good practice to ignore these files in the version control system. So we can create an example that contains only variable names, but the actual values will be empty. Copy our file and create a new one, .env.example. Then remove all values from it. This .env.example file should be committed to Git. Done. Now, having this file, we can read environment variables in our code. Here in server.php, create an instance of .env and provide a directory where it should search for a .env file. In our case, it is a current directory. Then load the file. Once environment variables are read, we can get them in the source code by calling getEnv function. Let's build a database connection string from environment variables: username, password, host, and database name. Replace this hard-coded string with a connection string. Now, to prove that our code actually works and we have a working connection, let's query something. For example, let's select all tables. Method query returns a promise that resolves with an instance of query result once the query is done. Let's just print result rows. Start the server. Yes, it works, and we have three tables here: doctrine migrations, products, and orders. Let's also replace hard-coded values in doctrine migrations config file. Require composer autoloader, instantiate.env, and load environment file. Then replace hard-coded values with environment variables. So with that, we have configured the database. We have done quite a lot of work: migrations, environment files, and the database connection itself. But it was worth it. Now we are ready to execute queries, and in the next video, we'll start adding a database logic to our API endpoints.